Good day, Doctor. Today our group 2D are going to present on solid liquid extraction. So, what is solid liquid extraction? Solid liquid extraction is a method of isolating solid mixtures by specifically dissolving one or more components in a solvent of a fluid. It based on the effectiveness of various solvents or through extraction using hot water. It most commonly used method for preparing solid sample using analytical chemistry. There are three key mechanisms which help to control the process. First of all is the penetration of the extracted into the solid matrix. Secondly is the diffusion of analytes to the external environment. Thirdly is the solvency of the analytes in the extracted. To increase the efficiencies of the process, we can utilize the high temperature and high pressure with the combinations of implement auxiliary energies which are microwave and ultrasound. It is an automation of processes which can help to improve performance and consistencies. Furthermore, it helps to decrease in extraction time. Lastly, it can help to reduce in consumption of organic solvents. The objective of this experiment is to extract sugar from sugar-impregnated vermiculite using solid liquid extraction.
Let's look into the materials, machinery, and methodology behind this experiment. First, let's take a look at the materials and equipment required for this process. On the left, we have sugar-impregnated vermiculite, a porous mineral substrate that has been saturated with sugar for the extraction process. Its unique structure makes it ideal for efficient solid-liquid extraction. On the right, we see the arm-fit solid liquid extraction equipment. This setup is specifically designed for experiments involving the separation of solutes from solids using solvents. It is equipped with multiple valves, vessels, and heating elements for precise control of the process. Now, let's move on to the methodology used in this experiment. The process begins by preparing 220 grams of sugar-saturated vermiculite, which is securely packed into a sample bag and placed into the extractor vessel. Next, 3 liters of water are added to the solvent vessel and the pump is activated at 60% capacity. The solvent vessel's heater is then turned on, gradually warming the water to a target temperature of 55 degrees Celsius. Once the setup reaches the desired temperature, valves V5 and V1 are opened, while valve V6 is closed. Valve V7 is adjusted to direct the extracted solution to the appropriate outlet, ensuring all other valves remain closed for controlled flow. The pump is then fully activated and samples are collected at regular intervals. Specifically, 10 milliliters of the solution is drawn from valves V8 and V4 every 5 minutes. During this time, the temperature at the T2 thermometer is also recorded to monitor process consistency. Finally, the Brix value, which measures the sugar concentration in the solution, is determined using a refractometer. The experiment concludes once Brix readings stabilize, indicating that there is no further change in sugar extraction.
My name is Lau Kai En. My machine number is 223788. Now I'm going to explain about this equipment. This is solid liquid extraction field equipment. There are a few readings that we need to take, which are temperature T2, the purple circle, Brix value of V4 valve, and the Brix value of V8 valve, which are the two orange circles. Now I'm going to explain the flow of sugar extract in this machine. First, the pump is turned on. From the extractor vessel, the green circle, water will flow through saturated vermiculite and extract it. The extract then go downwards into the solvent vessel and also go through the V4 valve. From solvent vessel, the diluted extract will flow towards V8 valve through the lower pipe. It will mix the extract that flows through V4 valve also. Next, the mixed extract will be pumped by water pump and flow through V7 valve, which direct the extract to right, and V5, which allow the extract to flow back to extractor vessel. The flow cycle is now complete and allowed to repeat until there are no changes in Brix value of the sample taken from V4 and V8 valve.
Today, I will be presenting the result and the discussions of our experiment on solid liquid extraction, where we aim to remove sugar from sugar-impregnated vermiculite using a solid liquid extractor. The main focus was to demonstrate how extraction time and solvent flow rate influence the efficiency of sugar extraction, which we measure using the Brix value. This experiment also helped us to understand how solid liquid extractions work in food processing industries, especially in processes like sugar extraction. Before diving into the result, let me explain the Brix value. Brix value measures the concentrations of dissolved sugar in a solution. Specifically, it tells us how many grams of sucrose are present in 100 grams of liquid. This measurement is widely used in food and beverage industry to assess sugar content in products like juice, syrups, and wines. In this experiment, Brix helped us to track how much sugar was dissolved over time. The main reason why we used Brix was to quantify how effectively sugar dissolved in water throughout the experiment. The Brix measurement showed that water is good solvent, progressively dissolving the sugar while passing through the matrix of vermiculite. This illustrates how solvent flow and extraction time to interact to maximize the extraction efficiency. The final stabilization of Brix value indicate that under such conditions, the process was at its limits and the majority of the extractable sugar had been dissolved. Looking at the result, the Brix value consistently increased with time, showing that sugar was continuously dissolving into the water. For both valve 4 and valve 8, we observed that the highest rate of sugar extractions occur during the early stage of the process. This aligns with the theory of diffusion, which suggests that a higher concentrations gradient between the solid sugar and the solvent leads to a faster diffusion rate. Eventually, the Brix value stabilized. This stabilization tells us that the solution reached its saturation point, meaning most of the extractable sugar had fully dissolved and the process could not continue further under given condition. In conclusion, the experiment demonstrates that water efficiently dissolves sugar over time, with the Brix value providing clear evidence of this process. Once the Brix value stabilized, it confirmed that the solutions had reached its limits for sugar dissolution. This finding highlights the importance of Brix measurement in understanding sugar extractions and solubility, especially in food processing application.
Now, I will continue to explain two graphs of the result, which are the graph of sample concentration of valve 4 versus time, and also the graph of sample concentration of valve 8 versus time. Based on both graphs, like what my teammate mentioned previously, the Brix value, which represents the concentration of dissolved sugar in the solution, will increase with time due to the higher rate of diffusion initially, until the equilibrium was attained. And here, we can observe that the overall Brix value at valve 4 is higher than the overall Brix value at valve 8. It's because the liquid obtained at valve 4 is directly from the extraction phase, since the valve 4 is located near the extraction point, whereas the liquid at valve 8 might have already undergone further dilution throughout the pathway. Moreover, some factors such as temperature, solid-solvent contact might also affecting the solid-liquid extraction process efficiency, because higher temperature will generally increase the solubility of sugar in the solvent, and also the greater the surface area will increase the exposure of sugar to the solvent. Of these factors will facilitate the better solid-liquid extraction process.
For the conclusion, as the time increased, the breed value for the VAV4 and VAV8 increased. The effect of the solvent with each water in the extraction process was demonstrated. As more water flowed through the sugar-impregnated vermiculite, more sugar will dissolve. Thus, objective is successfully achieved.